Hello, this is Hayden Ireland with Electric Supply and Equipment, and welcome to another edition of Office Hours. I'd like to extend my gratitude to everyone who was able to attend our Automation Expo this year. As a special thank you, on this Office Hours, we'll be streaming Rockwell Automations' presentation on what's new and next in Logix. It is essentially a 2025 technology update given by Rockwell's own Dennis Wiley and Liz Ball-Prozik, packed with great information about what's coming in 2025 and beyond. If you have any questions, feel free to leave a comment in the chat with your email address and we'll forward that information to Dennis and Liz. Now, without further ado, let's begin the presentation.
So we've continued our investment in Logix for a long time. Logix started in the late 90s, as some of you may know, and we've built upon our original platform and improved the performance, improved the hardware, improved all of the features and experience. And so this is all about our hardware updates. So here we have some examples of our updates, which we've made to the hardware itself. So the look and feel of the hardware itself, you may have seen, has been updated, and we're continuing to update this for a more modern look and feel, and also for better visibility on labeling, on LED lights, and etc. So you can see kind of like what the product looked like before, and what we're moving toward in terms of the lenses, the door covers. And so this all isn't just about modernization, but it's also about improving the visibility of our products too. So these are some examples. These are the latest updates that we've made. So here you can see power supplies, terminal blocks, and the modules and the chassis there, from the original design to the new design. And these changes will be rolling out over the next few years. Gray market and counterfeit. This is a very important topic. So we have a whole team at Rockwell that handle gray market and counterfeit products. So we've seen over the years some customers have ended up with some gray market products, and we have brought them in and analyzed and taken a look at some of these. And we have some examples here of what some counterfeit product look like. They look very similar to what an actual authentic product is, and so we thought we would bring this to the presentation today for awareness, to always take a look at the labels, take a look at the product, the labeling on the outside of the box and also on the product itself. So you can see some examples here of counterfeit labels. And we've done some improvements also on the labeling of the product to prevent counterfeit. So again, this is one counterfeit versus authentic. So, they look very similar here. So it's kind of hard to catch. But if you take a look on the other side of the slide, it's a UV mark. So if you shine a UV light, you can see, so we have some of these things on our labels now to help us see which ones are counterfeit and which ones are authentic. Okay, so some of the initiatives. We have now a product registration. So as soon as you get the product, you can register the product so that we can have the traceability of our counterfeit versus authentic product. So as soon as you get hardware, you can go in and do a registration of the product through the QR codes and serial number.
So we're doing that as an effort to help against the counterfeiting of the products. And that's measured in multiple digit millions annually just for Rockwell with regards to the amount of counterfeit hardware we're seeing. So this is a pervasive. It used to be Rolex watches, Nike shoes, Coach bags. Well, now it's, since COVID, the counterfeiters found an opportunity in the industrial space where factories were down, demands for products were high, availability wasn't there. They could sneak in using deceptive practices like in stock now, available with warranty. They never tell you where the stock is. They never tell you whose warranty, right? A lot of them procured products off of broken, damaged areas where they needed to be repaired. They just make the lights come on and looks good, put it in a box and ship it, right? So now when you register your products with Rockwell, using the mechanism here is either you can upload a bill of materials with serial numbers, and then we'll register it that way, or you can just scan them one at a time using your phone. You'll also get rewarded with a second year of warranty. So you'll get 2 years of warranty on a product just by registering the serial numbers. Right? And so you basically take ownership of the serial number, saying, this is mine, I'm registering it, right? And then you say, all right, it's been claimed, and then you get a second year warranty. So if you're an OEM or an integrator and you're selling a system that's got the products, make sure you're marketing on your side, hey, our company offers extended warranty on the hardware we're using. You're getting it for free. They don't know that you did anything special, right? So don't care. That's how marketing works, right? It's how you sell more of your stuff. So take advantage of registering it, claiming it. Now, if it's a claimed serial number saying somebody else has already registered it, you'll get notified immediately, duplicate serial number. So now that means, all right, what happened? Do I have the counterfeit one, or did the other person have the counterfeit one, right? That's where we'll help, right? Never be afraid to report these to us. We will never come after you as the consumer saying, oh, we're going to seek legal recourse against you. No, we want to talk to you because we want to say, tell us everything you can about the guy you bought it from. And usually we find it's from a guy that lives in a van down by the river, and we went to return it, the van is gone, amazingly, right? So he doesn't live there anymore. So just be very vigilant of this. We've spent a lot of hours, I'm talking probably months, troubleshooting customer complaints and issues that turned out to be counterfeit product that they put into the chassis, put into the systems, that were causing downstream effects. Lots of times it's power. We monitor our power rails and our products very precisely. We can't float it more than like 1/10 of a volt because that's going to impact safety reliability. So we can't do this. We have circuitry that does that. When the counterfeiters build these products, they don't know that. They just it's got to have 12 volts. So it's 12 volts. Well, it better be very good 12 volts. It can't fluctuate around. So that's how we catch a lot of these problems. Our downstream modules start exhibiting issues. So don't waste your time. If you call tech support today, they will demand, if you have a problem that you want us to investigate, they will demand that you send us a photo of the label. So not up for debate anymore. I know you're paying for contracts for support. Don't care. Right? You need to do that. Let us help you make sure we rule out someone sneaking an unauthentic product in there that is causing, first you're going to say, non-functionality, but the issue becomes those things are not even UL certified. They could catch fire. There's no testing done on counterfeits at all. So you risk destroying other things connected to it, or worse, hurting somebody because the product was just not going to function correct.
Okay, so I think we kind of talked through some of this already, but just leaving this slide up for a minute. Again, it'll wreak havoc on the system if you have a counterfeit product. So please be vigilant to take a look at the product and make sure that it's authentic, and follow all of the due diligence in procuring authentic products. Build America, buy America. So lots of our products, we're a North American company, we're an American company. They're all, many of our products are built in America. So this is, I think it's a logo that we have for our products that are built in America. So take a look at that one.
The BABA Act was something that was put in place by the previous presidential administration, right? It's just like if you go to Canada, they want it made in Canada. If you go to France, they want it made in France. So this was the America, or the United States' move to say that, look, it's got to have at least 50% content from the U.S., right? You can't go buy a box of parts from Taiwan, put it together in your garage and say, made in America. No, you just glued everything together in America. You didn't really make anything here, right? So when you get involved with government contracts, this becomes a big thing, right? So they're going to say, do you comply to the BABA Act, right? We have 16,000 catalog numbers right now that are BABA compliant, right? And what those are going to do is that meets it immediately, right? So we have manufacturing in the USA. We have several factories here in the USA. Our products are compliant. If you get into the position where you have to answer those questionnaires for the government contracts and things, reach out to the local distributor here, reach out to the Rockwell team. We've done them lots of times. We know the first time you have to navigate it, it's like, oh boy, right, don't worry, we'll help. All right, we've been through it. We're ready with our products, so just reach out to us.
In fact, a lot of our Control-Logix products are built down the street from our office in Cleveland, so very local to where Dennis and I live. Next, eco-design. So ESPR, this is all about our sustainability and how our products are built for and engineered for sustainability. So this is also something that will be taking effect in the near future for our products all over the globe.
So this primarily is your eco footprint, the green initiatives, right? So everything that you'll see is your carbon credits, right? So in Europe, primarily right now, this is sustainability is a requirement starting in 2027 that all manufacturers must comply with. You must be able to scan the product and retrieve what I call is like the baseball card. We've all seen baseball cards, right? The front is the picture of the player and then the back are the stats. Very similar. You're going to scan the QR code on so let's just say the picture. Now they're going to want you to report in as a machine builder, as a user, all right, what energy does this product consume? Does it contain recyclable plastics? Do I have to dispose of it a certain way? Can it just be thrown in a recycle stream or not, right? So all of that is going to be mandatory in 2027 to the point that manufacturers like Rockwell, we will not even be able to ship product through their customs or through the ports if it doesn't comply. This is tied to the CE certification of the product. I'm telling you about it now because we are trying to get ahead of it, and we know that just because our products comply, a lot of things you all do has more than our products in there, right? So just because we're ahead of it doesn't mean that everybody's going to be ahead of it. So this is your notice. Keep your heads up and eyes open, and don't let us sneak up on you because it's a fair amount of work to achieve these goals of, you know, the wattage rating of every tiny little part that's used inside one of our products and adding it up. So the DPP, or Digital Product Passport, that you'll start seeing very soon from Rockwell. And it's just that special QR code on the front of the product.
Okay, thanks, Dennis. Okay, now the fun stuff, the highlights. So this is what's new in our portfolio. OPC UA support in the Logix controllers was added in V36. So for small applications with OPC UA, you have it now natively in the firmware in the controller, again with V36. If you have a larger application which requires OPC UA and some other modern protocols like MQTT or REST, we have an embedded edge compute module. So this module is something that goes into the Control-Logix rack. We have another module called the Optics Edge, which you may have seen as well. That one is paired up with a Compact-Logix. And essentially what these modules are is an edge computing device inside of the chassis to extend the capabilities of the Logix controller. So you can do Dockerized applications, containerized applications with this module. You have FactoryTalk Optics natively on this module to do the comms, to do small applications for HMI, and also to leverage the Docker capabilities. So this is a really powerful module, which we introduced a couple years ago. FlexHA 5000 IO. This is our fully fault tolerant and highly available IO platform, which is used primarily for the process industries. So this is a universal IO module, which does a software configurable discrete in, discrete out, analog in, analog out, with and without heart. So it's a very powerful platform. Then on the end there, we have a new analog heart for the Compact 5000 portfolio. Continuing on with what's new, we also have a safety controller, which is now added to the redundancy portfolio. So basically taking the guard Logix controllers, putting them in redundant chassis to do SIL 2 and SIL 3 applications in primarily hybrid applications and process applications for, we call it Logix SIS for safety instrumented systems. We have another variant of the guard Logix, the L85ES, which is greater memory increase over the L84. So we introduced that a couple of years ago. We have the XT portfolio, which is all about hardening the product for harsh environments. So these are used for corrosive gas environments, and we have some more details on that, which we'll go through. And the most exciting, the new controller, which is the 5590 introduced later this year. So going a little bit deeper, OPC-UA and Logix. So I mentioned we have this capability now native in the controller firmware. And we also have it in the embedded edge compute module. And for the controllers, it's native on all the controllers, the P controllers, the standard controllers, the guard Logix controllers. So this was introduced in V36, as I mentioned. Jumping into the compute module. So this module, we talked a little bit about earlier, but so this module is something you can add. It's not just paired with our later generations of controllers. You can pair it up all the way back to an L6 controller if you want to expand the capabilities. So it's for greenfield and brownfield applications. So it goes all the way from an L6 to an L9, as we'll introduce that later this year. This is this under the hood, it has a Linux Yocto closed OS, so it's a secure device. I talked about Factory Talk Optics. Jumping into the next slide, you can kind of see Factory Talk Optics allows us to do the comms, the contemporary comms, not just OPC-UA, but also MQTT. We also have the ability now to do Docker containers, so hosting applications on the device. So you can use kind of off-the-shelf technologies here, such as Node-RED, InfluxDB, and Grafana. And we also have an application called CordaSuite, which is kind of like a no-code, low-code application, which can just be used on this device. And we'll have demos of this at Automation Fair if anybody will be attending that this year.
There's another feature of that embedded edge compute, which is out of the box, it has secure remote access. So that module is about a $2,000 list price, but in the middle there, probably the laser won't show, remote access. So Factory Talk Remote Access is a very low cost way of putting that into a system and then having a secure ability to remotely connect to it. Right? So if you're looking to do that, this is a great thing for machine builders to have in there. So just note that as well. All right, so Logix controllers and redundancy. All right, so Logix started way back in the 90s, right? It didn't start doing everything it does today. It evolved into having integrated safety, integrated motion, integrated process, right? So it's taken some time, but multidiscipline for us means everything goes into one controller. You shouldn't have to buy a safety controller, a motion controller, a process controller. We want it all in one ecosystem, right? So Logix, we're gonna build on that legacy, right? So we always say protect the installed base. You know, these things have been going since 1999. You can take modules today of this vintage and plug them into those old systems and it works. Likewise, you can take modules from the old systems and bring them forward into the new ones and they will equally work. To a fault, it is why people stick with Rockwell mostly is because of that long-term supportability and that backwards compatibility, right? Protected investments you've already made. With that, we've added some more contemporary things with regards to cybersecurity and locked them into our controllers starting just one release ago. Right? So all of our controllers now support SIP security. Right? In today's cyber-aware environment, right, you have three choices when you turn on a controller. You're in authenticity, integrity, and confidentiality. Most of the time, folks are not turning on all of these levers. They're turning on the authenticity lever to make sure that the I/O device, the drive, the PLC, the HMI, that they're authenticated to talk to each other. So nobody can kind of get in and play this man in the middle, as you see here, little script, right? So these are all built in. It's built on our 62443 compliance. So we are IEC 62443 compliant. We were the first controller to achieve that. We're going to continue that on. We are at 4-3, which now, or sorry, 3-3 is our system levels are now supported to cyber. So there are multiple levels to the 62443, and we've kind of pushed our processes, our designs, and now our systems are all compliant. So we're the most secure controller out there. I'm pretty confident of it. Guard Logix controller. So Guard Logix, there were several things since we last saw a lot of you around COVID time. All right, a few things that got added that we'll just highlight. One of them is adding the access test mode. So now with a safety controller and our Factory Talk Echo, you can actually go in there and you can emulate motion running in the controller. So you don't have to have a big system. You don't have to have something like, the side track over here. You can do it all on a PC, simulate it onto the PC. So you can test out code in a hotel room before you ever get anywhere. Is usually what we say. Safety signature elements. How many people use safety controllers today? I don't want to go too deep into it if nobody does safety. Okay, just a one or two. Okay. So safety controllers, when in a safety controller, safety application, for those who don't know, you sign it. It's a signature that goes on your project so that you can guarantee, has anybody tampered with it? All right. Once I prove my safety code works, I don't want anybody to tamper with it, because if you tamper with it, then you're going to break it. So don't break it. So when you do it, you can sign it and say, I'm locking it so that if anybody messes with this thing, the numbers are going to change, the code's going to change, and I'll know. Up until this feature, you did this to the entire controller, which means everything about the configuration of your I/O, everything about your program was locked under one signature. So if you made one small tweak in one subroutine someplace, you could never demonstrate to the inspector that's going to come for your safety prove out to say, all I changed was that thing. That inspector is going to go, you're going to walk through the entire machine. Every e-stop, everything, because you have changed the program and it's a safety certified application, right? So now you'll be able to take that much more granular and demonstrate to the inspector, look, it was just a subroutine. It's the only key that got changed. You don't have to prove out everything, just that. So validation is much, much quicker. I'll show you a little more on this Logix SIS and burner management with two new disciplines that were added to the Logix in the safety area, were burner management and then SIS. I'd like to control myself a script. So this firmware has to go to these 10 controllers. I want to flash all 10 of those controllers. Then I want to push it download to all 10 controllers. Right, so you can script out how you want to deploy it all through this Logix Designer toolkit. Right, there's a book on it, tells you all the things. I'll show you another slide at the very end, I think, about that one. Right? Redundancy, anybody do hot backup redundancy systems with Logix? If you do, today we have an RM2, it's a redundancy module, it's a number 2. We're making a number 3 only because the number 2 was getting old and we wanted to get some fresher parts so that it could live for the next 20 years. So we made a number 3, RM3, same functionality, backwards compatibility to all those controllers and all those systems. It's simply a parts refresh to make sure, again, that protect that installed base that's already out there. So in a redundancy system, so a single PLC, single application. In a redundancy system, you would set up a duplicate PLC, and then with the RM modules, the redundancy module, you would run a fiber optic cable between PLC number 1, its RM module, to PLC number 2, its RM module. And then what they do is they watch each other over that fiber optic. All right, I'm okay, everybody's okay. All right, they're checking what line of the program they're in, what data they're moving, and everything's good. If the first one, let's say, struck by lightning, somebody turns the power off, because the other one was right alongside, it's like, oh, where's my friend? He's gone. He just steps right in and assumes responsibility. System keeps running. Nobody knows the wiser. Little red light goes on and says, all right, I am now operating on a secondary PLC. Something happened, but the process is still running. So I always use the example, if I'm in a steel plant and I got one of those big hot ladles full of molten steel and I'm moving them through the plant, if that conveyance system stops for any reason and that steel hardens inside that little metal vessel, you dynamite to get that out of there. It's a very messy and long process, and they're down for at least a day. So you never stop molten steel, right? You can get it to the end. So something like that. A refinery, where if I lose control of the reaction of making gasoline, something happens. Big explosion. Now I didn't ruin a metal container. Now I've blown up an entire plant, potentially the entire city, right? So there are applications on the planet that says, look, these are mission critical. I can never stop. I want a backup system. That's what this module does. Guaranteed switchovers in less than 200 milliseconds. if I get my numbers right. Right, we hold the I/O for that quick quarter of a second while we switch over and then just keep on going. So we can do redundancy all the way. So it's like, I just care about the power supply, so we can just do redundant power supplies. Or I can say, I care about the PLCs too. All right, so now dual power supplies to every PLC rack and then duplicate that. And then he says, well, in my place, they're always breaking the network wires. All right, then we'll do dual network connections. We'll build a nice ring or a PRP network and we'll duality there. And this is, well, we even want to go down to the I/O. So if you're in the oil and gas business, even your I/O card, you may not tolerate a single I/O failure because bad things will happen. So we have, as Liz talked about, fault-tolerant I/O. That you wire as the user one sensor, and then our system will divide it across 2 modules. And this is, all right, you got a backup. So if something happens, one goes away, don't worry, we got a second one. And then you can replace them. While it's on the backup, you replace the dead one, and it says, all right, now I'll be your backup now. Right, as long as you have a time period to fix it, usually a matter of hours, right, before the safety guy gets concerned. Right, so, but yeah, if you want to do redundancy, it's a big deal. It's really easy for us as Logix. We made it so as the user, you just simply duplicate the hardware, wire it correctly, and check a box in your project that says, I want this to be redundant. I want you to make sure there's a backup system running. Check the box. We know what to do behind the scenes. We take care of all that configuration, all that. You download to one controller, and then we, as long as we can see it, like you said, you wired it right, we take care of putting everything in the right mode all throughout the system. You don't have to do anything, right? We've been doing this 135 years at Rockwell. We figured it out. Probably easier for us to just do it than tell you a book of how to do it. So that's how we go about it. So yeah, redundancy, big deal. A lot of people are using it and more because it's so easy. And with that, so that was standard control. Now what if I had a safety controller that had the same needs? I needed redundancy for that because, it's a safety system. Maybe I'm, again, running a refinery or something like that. So now we can take that safety, elevate from a standard control to a safety rated controller, where now the duality is you have 2 safety controllers, and a safety controller and a standard controller are slightly different only because there's 2 CPUs in a safety controller and they double check each other. Right? Just like in a redundancy stuff, somebody said you have 2 separates. In safety, we build that redundancy inside. So then you have redundancy inside to redundancy outside, and again, you can go all the way down to the I/O. You just have to pick where's the critical pain point for your system. We can cover you soup to nuts, top to bottom. Right? As little or as much as you want. The safety roadmap, so this guard Logix in a safety controller was something relatively new. You'll see it, BP Oil and those guys, the blowout preventers and things like that might have systems like this on here, right? So we have right now a core set of functionality in V37. We've got a couple things coming in 38, but you'll see we have a whole list of things we want to get to in the very near future. Other programming language like a structured text editor for this control system. Some more ability to configure things while it's all running so that you could change the configuration of an I/O module while it's actually running. So there's a little bit of invention taking place to create some of this, but very long list of functionalities coming to SAS very soon. Okay, with that, so we added Logix SAS, we added redundancy to the portfolio just this year. We're also adding burner management to the portfolio. So we've had basic safety instructions, light curtains, e-stop circuits, those types of stuff built in. We've added process instructions for advanced process PID loops, advanced process and loops, things like that. We are now adding burner management. Burner management is a set of instructions for controlling burner systems. Right? So there's 5 new instructions to do flame guarding. You'll see over here this BMS system. It's just a flame boiler, whether it's oil and gas, doesn't matter. And we have the instructions built into the product now.
So a lot of our competitors have a black box for flame safety. And so what the real advantages for these instructions are they're pre-certified and you can leverage your existing Logix system to just do all the flame safety rather than buying a whole separate black box. So you're really reducing your footprint and putting all the functionality into your Logix controller.
Yeah, and the complexity, because you're managing this black box is another computer dedicated just for that one function, and then you're left as the poor person who has to try to integrate this black box to the other thing that you already know, Logix, and then trying to get that all certified, because when you're doing flame safety, those are the things that will explode, so there's definitely an inspector going to be looking at that. All right, so this is now integrated. If you know Logix, you could do this. Even if you're not a burner, this is going to get you far enough down the road, you should be okay. Target industries for this, you'll see there's lots of things. Lots of places where there are ovens, traditionally food, beverage, auto, life sciences, that type of stuff. Mining applications, some chemical production, those types of things. Okay. All right, XT, corrosion resistance. So Rockwell spent some time over the last decade, basically. We do continuous quality improvement at Rockwell. So we're always monitoring product returns. We're always monitoring customer complaints. Customer brings something up to us, and we look at things, and we have a standard that we believe is higher than anybody else's. And we start seeing products that are failing, even though they're well outside of warranty, still not where we like them. We try to, like, 15, 20 years, and it makes me happy. Anything less than that, I'm like, why? Why did that one not live that long? So we can start looking. What we noticed recently is there have been some changes in industry. This is going fiddle. What we found was, first off, we'll kick off with, we have a very massive chem and materials lab at Rockwell. So we can take, and you send me a failed module, I can put it into here and I can get microscopic pictures. We have electron scanning microscopes, we have spectrometers, I can tell you what that substance was. If it was a contaminant, I can tell you if it's corrosion, I can tell you what it consists of. So we know everything about a return when you send it to us, right? So this lab, and we started looking at some of the returns, and lo and behold, under the microscope, we're seeing, what you'll see here is these either dendrite growths, like in the upper, the spiky things you see there, or creep corrosion, like you see on the edges of some of those things there, right? You don't normally see it. You take it out, you look at it, the module looks very clean. It's not dirty, but under a microscope, you notice this. Well, these are artifacts of gases that are present in the manufacturing process in general, but also these component manufacturers, as we've moved to miniaturization and that restriction of things like lead into some of the compound, we get all that stuff out of there, that tends to now drive some corrosion behaviors that before we didn't see. In the old days, when the parts were separated through hole parts, but big leads going through a board versus the size of a grain of rice on a board, if you had a corrosion or a rust kind of a condition, it would do it for a decade before it ever touched the other side and short-circuited. Now, a flake of anything, and because it's so fine of a pitch on those parts. So we saw this, we started looking at it. Well, we know it's reactivity compounds in the air. We also know that heat and humidity contribute to it, and it varies everywhere. So we contribute a lot of what we were seeing to miniaturization and these components that, let's just say they're not as protected from the environment as we think so. The way you check your environment, there's a Purifil coupon. It's a company called Purifil. You hang this up there. There's a bare copper bar, bare silver bar, and there's a little tab on the side that monitors temperature and humidity over time. It's a little computer. And you hang it for 30 days, and you let it corrode. You let it just build up a crust, right? And then you send it in an envelope, prepaid envelope, back to them, and they give you this wonderful dashboard that says, these are the chemicals that we see. This is how quickly it rusted or corroded in those 30 days, right? And they will attribute it to a level of corrosion in your environment, to which then, as a design engineer, you can say, all right, I know I'm really corrosive. I got to buy a NEMA 4X box, or I'm going to need an air exchanger. This is what's supposed to drive a good design, right? Is know what the environment is you're going to expose products to. They'll grade you on a level mild through severe. Thing to note on this one is once you get to 2,000, and these numbers are called angstroms. It's a chemical term for the thickness of the corrosion they measure, right? So 2,000 or more angstroms is considered severe, right? I want you to note that because what we found in our testing was people were testing their environment, yes, but they're doing it with copper. And they were arguing that nothing's changed at their facility and everything is great and we checked it and it's all good. And then when we put the Purifil coupon in there, copper was good, but silver, which is a big high content in a lot of modern electronics, was not, right? 10 times the amount of corrosion was seen on on silver versus copper, right? So you'll get a false sense of security if you don't do the full test. A lot of the competitors that we tested against, they do a single gas test and go, we are good on copper for chlorine gas. Okay, well, I don't know any place on planet Earth that's just got one gas in the atmosphere. But okay, I guess that's good to know, but usually we have nitrogen and oxygen, carbon dioxide. I mean, those things kind of work and mix together in my high school level chemistry class. I think I remember that, right? So you got to work the whole thing. So Rockwell's done a lot of design to say you can't work with some of these industry standards because they're going to give you this false sense of security. So for 10 years, we kind of developed our own testing. Here's another example before I do that. When we looked at a plant, it depends on where they test. We have done corrosion testing. We don't have a problem. We want to know where they did it because we found sometimes the parts rooms were worse than the actual machine. And when they had a failure, they'd go to the parts room to get the replacement. And because the parts room was worse, the product was already dead in the box, corroded in the box, sat there for 2 years just steeping in this nasty air. And when they opened it, all the Ethernet jack was all corroded over. Corrosion-resistant components, I said, we start with parts that are known not to have these exposed metals that are going to corrode. We do use conformal coating, but we use an enhanced process. We work with the manufacturer of these coating machines to come up with a special machine where we can coat and cure in place. You know, we know just like if you paint anything, paint tends to try to self-leveling it. That means any high-rise part, like a memory device or a capacitor, if you coat it, the edges at the top, the coating is going to run right off, right? So, and the places you need your protection is right where that solder joint is, right? So if it's running off the edge, you don't really have protection. So we've developed some new techniques. We've even gone so far as the packaging now, because I told you it rots in the box. The packaging has been updated and it protects it. There's a special package now that has a copper filament in the Mylar bag to act as a protectant against some of this. So these products are going in our standard portfolio. You're going to see versions of these from us, from our friends in the PowerFlex drives, from the Kinetics drives, and a lot of our intelligent devices products are all going to have XT versions of the product. We're just one of the first ones to come to the market with this. Cost adder is about a 20%. So you may not think you need it, but just stay vigilant. You'll see this kind of stuff. We're hearing a lot more about it from the customers. So here's the evolution. For those that are newer, on the far left, 1997 we began as just a gateway system. We were just a chassis with comms modules. Very slowly, we started adding capabilities. First, controller. All it did was a PLC5 replacer. Didn't do much more. Right? But you'll see, then motion control came to the platform, followed by safety, followed by some kinematics robot instructions, followed by all sorts of new capabilities as you go across. So you'll see the red lines of the circles are the hardware drops that we've had over the years, right? And, we see an L6, an L7, an L8. I bet you could take a guess at what the next one is. 9. Let's look at what this thing looks like. So everything about this product, if you think of the current portfolio of today, the L8 controller, this is twice what that product is today, right? Twice as fast, twice as much memory, twice as capable, right? Everything's twice, but the price. I know it's hard to believe it's Rockwell, but the price is not going to be twice, right? It's a 5% premium for this. So what I'm about to tell you about is only a 5% adder. The team worked really hard to keep our costs as low as possible so we can give you a more powerful product that is as close to the same price you're paying for today. We did not want to raise the prices if we didn't have to. So it starts with performance. So if you are an L7 user, which is a majority of the users right now, this is a 40 times improvement over that performance. That means more parts per minute off the line. That means more communications, more robots being controlled in one controller. As part of the improvements, we're also taking safety, and where safety used to be a red device, safety is now being integrated into the standard product. So just like you buy a car, they don't ask you, would you like the seat belts and the brakes to go along? It's like, no, safety better be there, right? We feel the same way, right? So we used to sell a red and a gray and it was the same price. We worked hard and we got it all in the one unit, right? So this unit is safety capable out of the box. If you don't need it, don't turn it on. It's like air conditioning in a car. If it's cold out, don't turn it on, but it's there for when it does require air conditioning. So same thing here. It is built in. For those users who absolutely don't want to see it, our software will allow you to just make it go away. right? But it'll be there automatically, no additional charge, no subscriptions, no licenses, one catalog number that does everything. Use it if you want it. So as we do, the increased memory is moving to 80. So we have a 40 megabyte limit today. It's going to go to 80, and I'm going to have a low-end version at 2 megabyte. So if you do have a smaller system and you are finding ControlLogix is just a little too pricey, I've got something that's several $1,000s cheaper now at the bottom. Right? For those smaller systems, it's like, if it was just a little bit less expensive, maybe. Now we have it. So it'll be a nice low end, and then the 80 megabyte, we're anticipating somebody who's using 2, 3, 4, the L8s might put that in to put everything into one controller. 2 Ethernet ports in the front. Right? For the first time, ControlLogix will have a controller with dual Ethernet ports. These ports are capable of either independent addresses, which means you can segment the network, put an HMI network in a safety I/O network, or put an enterprise connection in a motion network, whatever you so choose, or you could build it as part of the ring. Close the resilient ring. So you have fault-tolerant networking right at the front of the port. Okay? Those ports can also be configured for what's called redundancy crossload. So if you really wanted, if you have that hot backup, that high availability system, and you wanted to move a lot of data back and forth between those controllers, we now are going to take advantage of that gigabit port so we can do it even faster than we could before. Right, we got these fancy gigabit Ethernet ports, we're going to use them for other things. So you'll be able to take an Ethernet cable between the two, and as the redundancy module handles the switch over to make sure all the I/O is being handled, we had 600 Ethernet devices on a single controller. That's an awful lot, but as you see somewhere around here, we have in-cabinet Ethernet now. We know push buttons are now on Ethernet. Well, we want to be ready for that because if simple devices like push buttons and power supplies and things are going to start coming to Ethernet, we want a device that's ready for that. So this will hold 600 of those connections. Motion control, twice as fast and twice the number of axes. So if you had a system today that was doing 32 axes of motion in a 2 millisecond rate, you'll be able to do 64 axes of motion in that same 2 milliseconds. So double the number of servo controllers, or take your 32 axes and run it twice as fast. So take it down to 1 millisecond so you can get more even precision motion. Okay. Under the hood, this is kind of what it looks like. A little bit different than every controller we've had here before. What's the first thing y'all notice if you're a ControlLogix user? What's different? There's no key on this one, right? So the key was always never really a key because they were all the same, right? It was just an operator handle that looked like a key. It was that shape so that we know people with PPE on, gloves, they need something to rotate. But then as we went through life, it's like, no, we put it in run mode and leave it forever. It's like, so we spent a lot of money, and that keyway takes a lot of space. You see the little black circle that the key plugs into, but it's as big as my thumb. It sticks inside the product, and it's over the top of the circuit board where I want to do other things. So we wanted to get rid of it. We're going to this toggle switch, same as we do on our compact or smaller Logix controllers today, same kind of switch, proven in use. You lock it by just putting it up into the run mode. Just the same the other way, you rotated it and put it in the run mode, right? So it's no different functionality. We're moving to a micro SD card, so a little smaller SD card now, but you're getting a pretty big size version of that. That card is not required to run. It's in there should there be a fault of that product, and then you want us in tech support to kind of look at what's going on. When that thing faults, it takes the entire memory image and snapshots it to the card and makes a file. Every time it faults, and it keeps a log. Every time, bang, 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 date and time. So that if you have a recurring problem, tech support's going to say, zip up that folder and send it to me. Then our escalation team will take it and we'll install it on our controller, and then we can see exactly what your controller's doing using your file. So that's what that card's used for. It's also used for recovery. You can set it up to auto load, right? Should something happen, auto load, put me back in the run mode. Don't wait around for the technician. You can set that thing to automatically do that just on a power cycle if you want. Okay? Also USB-C, we're moving to USB-C. I'll head it off at the pass. No, you can't plug your cell phone in there and charge it. Every session I've done is like, oh, it's great, I'm gonna be on site. I can charge my cell phone right there while I'm working on it. It's like, No, it's probably not a good idea. It's like breaking security rules 101, but it won't work that way. We're a device, not a host port. We talked about that digital product passport. There it is on the front, the QR code under the hood. That's going to get you all that eco-footprint stuff, all your green credits. It's going to get you all the safety and security advisories that might be out on the product, firmware, software uploads, downloads, manuals. And if that's not enough, you still got a question, there'll be a big purple box that says chat with tech support. All right, so it's a one-stop shop for all your help. Okay? Catalog number changes a little bit. Instead of just a 1, 2, 3, 4, 5, we're going to take this opportunity to actually put the embedded memory size into the catalog string. So if you see an L915, that's an L9 controller with 15 megabytes of memory. So it's very, very easy to kind of relate this to. Everything will have an S in the controller type position, but you might see a PS. So plant PAX, there's a special process version of our controller that uses advanced process libraries of instructions. When you buy that with the L9, you will also get that SIL2 safety capability with that. So you're getting process and functional safety in one unit with the L9 now, which is again a new one. Everything being in one is never before been done. So here's kind of a breakdown for the techie people. Comparison L7, L8, L9, where kind of the big needle movers of attributes are. You'll see how pretty much down the list of the green, everything's basically getting a doubling, double of connections, double of buffers, double of just about everything. We're still characterizing certain things like alarm bursts, like how many alarms could go active at one time and what would this controller do. So we're like, 10,000 is what we say today is our limit. I'm trying to get to 20,000 or more. So we're just not quite finished yet with the product to run those characterization tests, but those are about to begin. So you can see some of them are targets. Also seeing the capacity as memory goes up, as we add more memory to the product, that's where you're going to start picking up the number of Ethernet devices. Right? So obviously, if you only have a 2 meg controller, the likelihood of you putting on 600 Ethernet devices, you're going to run out of ladder logic long before you're going to get to those 600 nodes. Right? So right, wrong, or indifferent, what I did is I got 600 possible. I got 6 versions of the product, divide by 6. Right, so some of you are going to get a deal and you're going to be able to buy down. Oh, this is nice, I bought down a level. Some of you, sorry, you're going to have to pay up one level. That's just the way it works, right? But again, no licensing, no subscription, none of that. It's just built into the product, all right? So just know that that's how it works. All right, so under the hood, these are 4-core CPUs. The way our 4-core CPUs work is the first core is what we call your logic core. That's where your app code is going to live. That's where you write your project. That's where it lives. In that code, also where your safety task is executing. But that safety task also gets executed invertedly on the diagnostics core, or I call it the safety core. So they run that code backwards, and they got to make sure they're always canceling themselves out. That's how I'm able to achieve a safety controller in a single platform, is I do it inside the chip, right? So as long as those 2 cores of the CPU are agreeing, everything's good. If they don't, they will put that into a safety halt, stop, something's wrong. It's like somebody hits an e-stop. Right? Something is not safe. Right? So diagnostic core. Communications core handles all your Ethernet traffic, whether it's in the chassis or out the front port. This is why when you set up your safety reaction time, your motion control axes, and you tune everything, and then you start adding more and more comms, we're able to maintain the performance you expect on motion and safety, and still add comms. It's not all lumped into one big bucket, right? So it runs independently. And then the last core does all your packet processing of all your I/O traffic, okay? There's a manual. If you've never seen it, I highly recommend it. See it down there in the red box, RM094. Lots of tidbits of how things run under the hood, how you can optimize, just how you create a tag, how it consumes memory, impacts the performance of the controller, especially if you're building big arrays, right? So learn it. It's a lot of big pictures for dumb guys like me. So go through it, read it. It's pretty interesting to go, oh, that explains why it's doing what it's doing. Now I understand. Right? So it's a good thing to have. So life cycle, as these come out, the L9s, we are going to have a life cycle change for the L7s. L7s are going to move to an active mature state. All active mature for Rockwell, what that means is it's the last 10 years of life. The first 10 years are active, means it's the newest product they got. Active mature means still available for sale, not going anywhere, but I have a product that's newer. So think about they sell you an iPhone 16, they still sell iPhone 15s. Okay, well, the 15 would be an active mature because I got a 16, and if you really want new, you should go with the 16. That's kind of what we're doing here. So active mature for the L7, it starts its last 10 years or 10 years or less. So this is when you start planning. This is when you work with the boss out, hey, how many spare parts are we gonna buy? Or we gotta do a modernization effort in the next 3 or 4 years. Okay, great. When I issue the end of life, that's when we're at a 1 to 2 year warning. Where I'm saying, put your tray tables up, seat belts on, we're coming in for a landing in 2 years. Now, it's a 1 to 2 year because it depends on commercial demand. I have a lot of people that'll buy lots of spares, and I have other people who won't do anything. Right? So sometimes I find I'm bought out of my remaining units early. Other times I find I hit 2 years and I still got lots left. Right? I can't promise you which one it's going to be every day. Right? So when I tell you active mature, that's your planning time. When I say end of life, you have 2 years to execute your plan. Right? It's more time than the component guys give me, so. Firmware for the L7. So if you're standardizing on a version of firmware, version 38 for L7 will be the last. It is full featured. It's got all the capabilities, right? So we're going to freeze it there. We reserve the right to do releases if we find functional safety anomalies, things like that. We don't anticipate, because we've been doing this controller since 2010. We're pretty sure we got everything, but if somebody uncovered something, we would certainly investigate it and we would possibly patch that version 38. But right now, version 38 is it for the L7. In conjunction with some of the hardware, there's some software changes coming, but I'll touch base, and Nisha kind of commented on this a little bit. The Design Studio software, so a more cloud-native software experience is coming down the road, right? So a more collaborative environment, more like you would see with like Office 365, those kind of tools that we're starting to become accustomed to. That is the FactoryTalk Design Studio. It has a lot of these rich capabilities. It is available today, right? It's got a roadmap here. Kind of see where they've kind of worked their way up here. You can get a copy of it and start kind of kicking the tires and playing with it right now. It is not full featured yet. We showed you that evolution of Logix slide. It took a couple decades. It's going to take them a couple releases to get everything in here, right? But you can start learning it now, and you can see some of the capabilities that are there, including like AI Copilot, which is weird as that is. I mean, two things that I find really cool for that is I can tell it to build me a three-wire motor start-stop circuit, and it does. It writes me the ladder logic, and it's like, wow, that's pretty cool, right? Or you can ask it, hey, why is the motor not running? And it'll go through your code and says, well, the permissives to make that motor run were this one's not running. I was like, oh, sweet. I didn't have to go through the code. It just did it for me. So there's a lot of really cool things coming for us. Just don't tell the boss we're going to have all these cool things. You're going to look like miracle workers. It's like, oh, we can fix that in 5 minutes. Just ask the AI and it'll fix it for you. Right? So there's a lot of cool stuff coming. For software, you'll see, we're beholden to this. We get nothing different at Rock. We don't have different software, different tools, different Microsoft builds. When Microsoft says something's going, it's going, and we got to move. So you'll see kind of what the support is coming, version 36 and 37 of what servers are kind of going away. The 2019 and 22 server is going away. They're going to move to 2025, right, in version 38. So just take note that your IT department's got to be bringing you forward to use this stuff. Okay. Kind of in review to now, you can see version 36 was mostly OPC-UA and a couple other instruction changes. Version 37 focused on the Logix SIS, the Safety Instrumented System. And version 38's primary focus is the launch of the L9. So this kind of gives you the last few years in review. Other things that we're doing that you should have note of, there's been some instruction changes, right? So for us, we try to comply to the 61131 standard as much as we can, but we also have some older instructions, like ours is called MOV for a move. Well, they really want MOVE. They like to have the E. So we're kind of getting pushed to say, Rockwell, you got to do it our way if you want to get the certification, and we do because it's what we do. So you're going to see some instruction names change. We'll flag it for you in the software. If you use the old one, we'll tell you what it is. But just know it's coming soon, right? Things like PIDs are going to change. PIDEs are going to be PPIDs. We're also going to look at some new instruction guardrails. So there are things that you could do in our software, I'll say accidentally, like putting in negative timer values, let's say, or trying to adjust a message instruction while it's running, that could fault the controller, take it out of run mode, right? So the software team is now working to put some boundaries in there. So those instructions, they're going to kind of monitor what's going on and make sure they at least warn you to say, okay, if you proceed any farther, we know what's going to happen here. So you're going to have some new guardrails to kind of protect you a little bit there, as well as some more enhancements. We know download times. We know some of the edit times can get long on some of these big projects. The software team is always cranking through to see what else can we do to make it even faster as it goes, okay? So safety is enabled by default now out of the box. We talked about that in an L9. You turn it off if you don't want it. It's easy enough. Process safety, you're going to have both the SIS, L9, and burner management. Everything is going to be in one controller platform when it launches, right? So you'll have process and safety in one unit when it launches. And then we have the dual front port now. So you really have a lot of flexibility in how you want to build your network. So you can have more segmentation right on the controller, and you can still add more Ethernet modules in the rack. SIL2 out of the box, we talked about it. Safety, we try to make it as simple as possible. Just hit a checkbox to turn it on and off. Lots of code behind the scenes to certify, and make sure that works as it's supposed to. But that is all it takes to turn on safety. You'll see some changes on the controller properties, a little more rich information about what's available, memory and connection counts and things like that. So a little bit more of an experience. You'll see your safety and your standard memory there. We talked about that one. And Logix SIS, the same thing is when you enable safety, then you have one more checkbox to say is you want that safety to be redundancy enabled. So keeping it easy for the user. And then we talked about process controllers with safety. Okay, and I think that's taking me into the PIDEs and catalog numbers. So there is a difference in catalog numbers. We talked briefly, but previously we will allow you to select a parent like an L83 controller. And that worked for a K version of it, conformal coded. It worked for an XT version of it. It worked for a P version of it. Now it's going to be very specific. Again, as part of the anti-counterfeiting, part of this eco-sustainability, we need to identify every catalog down there, so we can't keep doing that parent-child relationship. So when the drop-down list of controllers in Logix Designer, you're going to see a bunch of catalogs. You pick the one exactly the one you have. And the icons change. That's what we came prepared to talk about. Right. Well, if there's no questions, we'll cut you out. You guys 5 minutes early to get to your next session. Thanks for coming.
That's it. I hope you learned a lot from watching. Now, if you like this live stream and want to learn more about ES&E, please like and subscribe to our YouTube channel. You can also register on our website and follow us on LinkedIn, Facebook, and Instagram to stay current on everything we have to offer. Thanks again for watching this edition of Office Hours.